Starting with the basics, electrons don't exist in the neat circular orbits that you might see in a high school chemistry diagram. That model, while it has its uses, is still a simplified version of reality. Electrons exist in clouds of probability, constantly shifting, constantly moving, never precisely located. And the thing about electron clouds, and more specifically the electrons within them, those electrons aren't always distributed symmetrically. At any given instant, the electron cloud around a molecule might be slightly denser on one side than the other. My go-to analogy for this is to think about a swarm of bees inside of a room. The bees might be completely spread out one moment, but then the next they might be congregated on one side, and then the next moment they might be up by the ceiling or crammed into a corner. You can think about electrons in a molecule behaving similarly, and it's purely statistical randomness, but for a brief instant, one side of a molecule carries a slight negative charge, and the other side carries a slight positive charge. We call this a temporary dipole, effectively turning the molecule in question into a tiny little magnet for a fraction of a nanosecond before the electrons shift again. But that momentary charge imbalance doesn't happen in isolation. The electron cloud of a neighboring molecule feels it. The negative side of the first molecule repels the neighboring electrons, pushing them toward the far side, which creates a corresponding dipole in the neighbor, which induces one in the next molecule, and the next molecule, and so on, cascading outward in a chain of momentary attraction.